So the first theorem, theorem 5.2, the perpendicular bisector theorem, says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. Any idea what equidistance means? Exactly, equal distance. Okay, cool. So how this works. You have to have a segment. So we'll call this segment AB. And then you need a line, so we'll call this line A. Or line L, excuse me. It says, if a point is on the perpendicular bisector of a segment, so this line needs to be the perpendicular bisector of AB. What does it mean if it's perpendicular? Good. What's it mean if it bisects it? Cuts it in half. So each of those sides would be congruent. We'll call this point C. So this is the hypotenuse part of it. If you have a point, or hypothesis, on the perpendicular bisector of a segment, then here's your conclusion. That point is equidistant from the endpoints of your segment. So the distance from P to A has to be the same as P to B. Those would be equal lengths. If I had, I don't know, point Q down here on line L, since line L is the perpendicular bisector of the segment, then any point on it is going to be equidistant to the endpoints. So QA would be the same as QB. Any point on the perpendicular bisector is equidistant to the endpoints. If I picked one way up here, it would be the same distance from A as it is for B. Got it? Okay. Converse of the perpendicular bisector theorem. We'll just keep it on the same page. Says, if you've got a segment and a point not on the segment, so that the distance from that point to the endpoints is the same, then you can conclude that P is on the perpendicular bisector of the segment. Okay, so this one starts and it says that if you have a point not on a segment and the distance from that point to the endpoints is the same, then it's got to be sitting on the perpendicular bisector. Thinking backwards. The first one said that if you have a perpendicular bisector, then any point on it is going to be the same distance to the endpoints. And this one says that if you have a point same distance from the endpoints, it's got to be on the perpendicular bisector. Okay? Okay, flip it over. Those are the perpendicular bisector theorems. This is the angle bisector theorem. Okay, what's happening here in my picture? Good, angle ABC is being bisected, okay? So, if I have a point, call that point E, on the angle bisector, then the distance from that point to each side of the angle has to be congruent. That's what the angle bisector theorem says. It says that if you have a point on the angle bisector of an angle, then the distance from that point to each side of the angle has to be congruent. Any point on there is going to be the same distance as it is from the bottom of the angle as it is to the left side of the angle. Look one way out here. Q on the angle bisector, so the distance from Q to the left side has to be the same as Q to the right side. Angle bisector theorem. Cool. Converse. If you have an angle and a point in the interior of it, CP is on the inside of the angle, and the distance from P to each side of the angle is the same, then you can conclude that PB is an angle bisector. So if you have a point on the inside of an angle and it's the same distance from each side, then it's got to be sitting on the angle bisector. With me? That'll make more sense when we kept going. All right, hopefully you had flipped it over and you're at the bottom of page 2 where it says the distance from a point to a line is the length of the perpendicular segment from the point to the line. It's the length of the perpendicular segment from that point to the line. Here's point P, and here's line L. P is not on line L. Which of my lines, the blue, the red, or the green, would you measure to know the distance from the point to the line? Which one would make most sense? The red one. If I was going to measure the distance between my point and my line, hopefully you guys would line it up so that they make a perpendicular segment, or they make a right angle. That's what the distance is. It's the length of the perpendicular segment. It wouldn't make much sense to measure the blue line because that's not really the distance between them. The distance is always the shortest path. Got it? Cool, flip it over. Your homework has no proofs on it, that's why I skipped the proofs. Your homework is all application. It's applying those proofs. Okay. So for number 1, find x, FB, FD in the diagram at the right. So what are we going to do to find the value of x? How do you know they're equal to each other? Or does it show that they're equal distances away? Do you want to phone a friend, Spencer? Bree? Because what? How do you know that? So just because angles are equal, the sides have to be equal? Oh.
Yeah.
Why would BF be the same as DF? Which theorem? Okay, where's your perpendicular bisector of the segment in this picture? Is CF getting bisected? No. What's getting bisected? Good. Angle BCD is getting bisected. See that? How these angles are congruent? Okay. So if you have a point F on the angle bisector, then the distance from this point to each side of the angle has to be what? Equal distance. Good. All right. Solve it. Plug it in. What's 2 times 8.4? 16.8 plus 5. Good. Then you have to find the length of FD. How do you do that? Plug it in. What's 7 times 8.4? 58.8. Good job. Minus 37. 21.8. Isn't that what we wanted them to be equal? Okay. I'm going to tell you a different way you could have explained it. That's the angle bisector theorem. Do you see that we have 2 triangles in this picture? Triangle BCF and DCF, right? Okay. They already marked these angles congruent. What about angle B and angle D? Are they congruent? Because they're both what? Okay, and then both triangles use what? CF. What do you know about the 2 triangles now? They're congruent by what? Angle, angle, side. What does it mean when triangles are congruent? All their corresponding parts are equal, so it wouldn't BF have to be the same as DF then? Okay, so you could explain it that way. Prove that the triangles are congruent, then all the corresponding parts are. You guys just all did awesome on your test on Monday about that, so.
I know, but it's just, it's way too
Bless you. All right. Number 2. Use the information given in the diagram. CD is the perpendicular bisector of AB. Find the length of CA and DB and explain your reasoning. Oh, sorry, is that what we were waiting for? Okay, CD is the perpendicular bisector of AB. So that means CD is making the right angle with AB, and CD is cutting AB in half. Okay, so C, it's on the perpendicular bisector. So the distance from C to the endpoints has to be what? Right, so what's AC? 5, good. D is on the perpendicular bisector. So the distance from that point to the endpoints of your segment have to be what? The same, so DB would be 6, good. So when you explain this, we're going to write a nice sentence here. AC equals 5, comma, DB equals 6. Since C and D are on the perpendicular bisector of AB, then the distance from C to A and B slash D to A and B is the same. So I said since C and D are on the perpendicular bisector of AB, then the distance from C to A and B slash from D to A and B has to be the same. According to the diagram, how far is point K, here's point K, from ray EH, here's ray EH. How far apart are they? 10. The distance from K to EH is that perpendicular segment, so they're 10 away. How about how far is point K from ray ED? Why? Good. KH is congruent to KD, and if we said this is 10, then this one has to be 10. So, since K is equidistant to both sides here of the ray, what can you conclude about ray EK? Good. EK is a bisector of angle DEH. Since K is on the inside of that angle, the interior of the angle, and it's equidistant to the sides of the angle, then it's sitting on the angle bisector. It's right in the middle. So it's got to be on the angle bisector. Well, since EK is now an angle bisector, that would mean angle CED is congruent to angle CEH. So for part C, how do we find the value of X? Anyone? Then do what? Set them equal to each other. 2x equals x plus 20. Oh, well, you answered it when you said they're congruent to each other.
See, I told you it was 20.
So x equals 20. Part D says find the measure of angle DEH. True. Okay. If x is 20, then 20 plus 20 is 40, and 2 times 20 is 40. And angle DEH, that's the entire angle that's getting bisected. So yes, this should be 80. Okay, like, yep, Alyssa. Number 3, part A. How far is point K from this ray? How far is it away? The distance is always that length of that perpendicular segment. So like if I wanted to know how far C was from EH, I would have to know this length here. I wouldn't say that one's 10. Does that make sense? Okay, and then it was marked congruent, so that's how I know ED was 10 away too. Okay. Cool. 2 diagrams, like 5 questions left here. 4 and 5 use this figure. You have to find the length of BD. Anybody got it? Why? CD is the bisector of angle ADB. This angle is getting cut in half. How do you know that? Well, the angle bisector theorem says that if it's on the angle bisector, then it's equidistance. But how do you know that this is bisecting this angle? Yeah, but what does perpendicular have to deal with the angle bisector? Here's a way you could think about it. AN is 8 and BN is 8. These are both 90 and ND is congruent to itself. What do you know about those two little triangles? By what? So when triangles are congruent, then what? Wouldn't AD correspond with BD? Okay, there's one way you could explain it. The other one is the perpendicular bisector theorem. If you have a point on the perpendicular bisector, then it's equidistance. Yep. Okay, part 5, or number 5. C is equidistance from what to what? We just said here that CD is a perpendicular bisector. It's cutting AB in half, it's making a right angle. So any point on that has to be equidistance to the endpoints. So if C is going to be equidistance from A as it is B. So this would be A and B. Okay, last one.